Greetings dear learners, I am faculty of physics at SRN International School, Jagatpura, Jaipur. Today we will learn a topic electricity taken from grade 10th chapter number 12. So let's begin the video. In this video I will cover topics like resistance, factors on which resistance depends, combination of resistor and heating effect of current. Now, first topic is factors on which resistance of a conductor depends. So there are three factors on which resistance depends. First is thickness, second is length, and third is temperature. So if the thickness of the conductor is large, in that particular condition, we will observe that the resistance is less. And if the length of the conductor is large, then we observe that resistance is also high. Temperature, we will discuss about temperature very soon. So according to the thickness, it is mentioned that the cross-sectional area of the conductor is larger, which allows large electrons to flow, and that's why the resistance decreases. Now length of the conductor is similar to the length of a hallway. The shorter hallway allows movement at a higher rate than the longer one. Temperature, the temperature of the conductor does have less effect in resistance. The higher the temperature is, higher the resistance. For example, when you turn on a light bulb, at the first instant the wire is cold and has low resistance, but as the wire heats up, it gives off light and increases the resistance. So this circuit diagram shows the same thing, high resistance. Now, did you know this important fact? When you double the length of wire, you double the resistance of wire. Whereas if you double the cross-section area of the wire, you cut the resistance in half. That is, thicker cross-sectional wire having less resistance. But if the length of the wire increases, resistance also increases. Resistance of a system of resistors. Resistor is known as passive two terminals electric component that represent the electric resistance as a circuit element. The current passing through a resistor is directly proportional to the voltage across the resistor terminals. Thus, the resistance is the ratio of the voltage applied across the resistor terminal to the intensity of current through the circuit. V is equal to IR. From the Ohm's law, we have derived this expression V is equal to IR. V represents voltage, I represents current, and R resistance. Combination of resistance. The combination of resistance are of two types: resistors in parallel and resistors in series. When we talk about resistance in series, resistors that are connected in series where the current flows through them after one another is known as resistor connected in series. Here the circuit diagram shows the same thing. Two resistors are connected through a single wire. Now let's have a look on the resistance in parallel. So resistors that are connected in such a way that the branch out from single point and join up again somewhere else in the circuit are known as resistors connected in the parallel. In the circuit diagram, we can see that different amount of current is passing through the different resistors, and a single potential drop, that is voltage, is applied across the ends of all the resistors. So this is the way by which we can connect resistors in parallel. Now, did you know a very important fact? For resistor in series, the current is same for each resistor, whereas the resistors in parallel, the voltage is same for each one. Now, next topic is heating effect of electric current. The heating effect of electric current is widely used today. It is well defined as the Joule's law. This law states about the relationship between heat and temperature. So the heat produced by heating element is directly proportional to the square of electric current passing through the conductor. The resistance of the conductor increases the amount of heat in the circuit. It is defined as H is equal to I square RT. It is also known as Joule's law. H, that is heat, I square is the square of current, R is resistance, and T is the temperature. So this is the way by which we can say that how the heating effect is to be applied. Practical applications of Joule's law. The heating effect of electric current can be applied to many appliances. These includes electric immersion, water heater, electric iron box. A good heating element has high resistivity and high melting point. Electric fuse in the application of heating effect. Now there are some other appliances, electric kettle, television, electric fuse also. So next topic is electric power. So when we talk about power, power is required to glow the bulb. In this diagram we can see that power is supplied to the battery. The following are the components associated with the electric power. The International System of Units, that is SI unit, defines that the unit of electric power is watt. It is known as power consumed by the device that carries 1 ampere of current when used as at a potential of 1 volt. Watt is very small unit. In actual practice, a much larger unit, that is kilowatt, is used, that is equal to 1000 watt. The unit of electric energy is watt hour. As electric energy is product of power and time, the commercial unit of electric energy is kilowatt hour, commonly known as a unit. 1 kilowatt hour is equal to 1000 watt into 1 hour is equal to 1000 watt into 3600 seconds. When we multiply, we will get 36 into 10 to the power 5 seconds. So this is a very common thing, that 1 unit of power consumption, we know about it from the commercial point of view. If you know that when electric bill comes at your home, you will find that 1 unit of electricity consumed, which is equal to this much amount of quantity in joules. So this is about that how we are going to talk about it. So that's all for this chapter, electricity. So thank you so much. Do like, subscribe our channel and stay connected. Bless your kids. Thank you.